Hello and welcome back to a time series analysis using Excel. I couldn't sleep last night because I wanted to implement uh, chances using a Will Hopkins approach, uh, and as suggested by John Fitzpatrick in the comments in the previous post, and in my answer, I wanted to try to implement that kind of approach into a same data set as we did in the previous video. So pretty much everything is the same as a previous workbook. I put the new chart tab. So pretty much everything is the same data set. Everything is the same. So before watching this one, please refer to the previous video. So we're gonna start again HRV. We're gonna chart the baseline. We're gonna chart the row data points. As you can see, we cannot see much. So we're gonna calculate the rolling averages of the data points. I'm gonna remove the individual row data points. I'm gonna increase this to 7 days. Baseline start 70 days before one point and last 41 days. Smallest worthwhile change is 0.5 times standard deviation of the baseline. One thing I put here is the error bars. The same thing as we calculate the standard deviation of the baseline, we calculate the standard deviation of 7 days rolling average. In other words, everything is the same, rolling average and the baseline are the same, just the windows of the rolling averages and durations are a bit different or longer. So error bars are actually standard deviations of the rolling average. And this could be considered, as I said in a comment to John Fitzpatrick, this could be considered a typical error. And using the baseline and a small worldwide change as a zone, we can see how much chances we have acquiring harmful, trivial, or beneficial effect. And what does that mean is that if we take one individual data point of the rolling average, so that's a mean of the last 7 data points, and it has standard deviation. So if we assume that those data points, in this case 7, are normally distributed, so they're gonna 60, if I remember correctly, 64 or 68% is gonna be distributed between one standard deviation. And it's like a normal curve that goes from somewhere here a bit to infinity, sort of speaking, but it goes here, and most of the data sets is concentrated around the mean. So we can use simple Excel formula to calculate how many, sort of speaking, how much of that normal distribution of the rolling average is below, is above, is within the smallest worthwhile change, and is below. In this case, below is harmful. Within the smallest worthwhile change is trivial, so it's not a big deal, and above is beneficial. I created a VBA code to do that. So using these 3, we can visualize each of them. So as you can see, for data point that's inside of the baseline, and the error bars doesn't go much above the baseline, the trivial chance, the chance of acquiring trivial effect is going to be very, very high. So if you visualize it, you can see a couple of data points over here. They have very small standard deviation, or in this case typical error, and the chance is almost 100%. So this is trivial effect, so because it's inside of the baseline. So that's for trivial. We can use this one to see certain points that are jumping out of the baseline, and that means they are approaching zero chance of being within the smallest or file change of the baseline. I'm very sorry, this is a different, it's really tough terminology, and it might leave you confusing, but it's, if you put it on paper, it's quite simple. I'm gonna try to put a picture in a blog post. So if it's close to the zero, that means it's above or below baseline, and that's a bit tricky. We can also use different percentages. I think Will Hopkins provided certain verbal instructions for certain percentages. So this is most likely, this is non-likely or something like that. You need to refer to the articles I posted. Again, this should be kind of a red flag that this score is starting to jump out of the baseline. One thing with this approach is that the way we set up baselines and the rolling average is going to affect these harmful, trivial, and beneficial chances. So if I start playing with the rolling average, we can see this one is changing. Same thing with the standard deviation or the error bars. And this comes back again to the saying that this is more art than a science. And art is in a way of choosing durations of the rolling averages, duration, selecting the baseline duration, and in this case also smaller profile change. If I change this one to be higher, we're going to automatically increase the number of trivial data points. I could probably calculate the average trivial score for all period, but that involves a simple math, and you can probably do it in a data tab. So let's get this back to 0.5, this to 7 days, and what happens if we select the static baseline as we did in our first video that starts for day 1 and lasts 41 days. Again, it's going to affect the trivial chances. One thing that's worth mentioning is that these are all 400 points already collected. But the thing is, when you start building it up from the zero, it's going to take some time to build up certain data set. So with a good data analysis, first you need to collect enough data and then perform some analysis. So I know a lot of coaches say, what's the point of collecting if you're not doing anything with it? But I believe there's a phase where you need to actually just collect the data. In the long run, if you're not doing anything with the data, that's a problem. But in a short term, sometimes you don't know what you're expecting, and maybe you're going to see some effects, maybe you're not going to see some effects. And as I said, in a short term, we just collect the data for the sake of collecting it. In a hope it's going to give us some information, but again, we need to build up certain data set to get some information back. Okay, this is trivial. Let's see harmful. Again, harmful is when the individual point and a typical error is way below baseline and way below the gray area or smallest profile change. So if I click harmful, I'm going to hide the trivial. You can see potential periods where there is a higher chance of the score being harmful, in this case dropping down the baseline. That's over here and over here. This is almost 100%. And beneficial, I'm going to hide harmful. Beneficial is over here. One thing to remember, the summary of harmful, trivial, and beneficial is 100, or 1 in terms of probability, or 100%. So the summary for each vertical line, these 3, 1, 2, 3, they sum up to 100. So again, compared to the last types of analysis, this one is, using beneficial or harmful. I would say, if you want to see if someone is overtraining, with the assumption that drop in HRV is bad and increase in HRV is good, which might be flawed. Again, with the assumption that it's bad, harmful, chances might give us some indication of when we are really, really jumping out of the baseline. These numbers are, the chances are dependent in how do we set up the baseline and how do we set up the rolling average compared to the previous chart when we had the effect sizes that are not related to a baseline in this case. So they are only related to, or actually they are. Yeah, I'm sorry, they are, because the baseline is also shifting and changing, but they are not related to a smallest work file change. I can play with this one. The bottom effect sizes and daily z-scores, they ain't gonna change with the change in the smallest work file change. In contrary, the chances are gonna change. And that gives us more degrees of freedom, sort of speaking, in selecting the good smallest work file change, rolling average, and the baselines. I urge you to play with the data and see how how the data and chances behave based on a smallest work file change. Just playing with these buttons. I'm going to show you what happens with the HRV divided by HR. So again, we can use this one. As a coach, you probably, or as a sports scientist, you're gonna probably confuse the coach if you show him this one. So you can set up certain flags and say that if a harmful if the harmful effect has more than 50% chance, that might be red flag. So everything above 50 or any other number, again, depends on which one you select, or cost, or sorry, of risk ratio. So if there's a higher risk of something, you're probably going to decrease the red flag, and if less, then you're going to probably lift it up. So again, that might be additional variable that increase degrees of freedom and increase the artness in all of this. So long story short, we started with raw data points that look like this. Again, it looks like a I don't know. It looks like something that we cannot pull anything out of it, on a first sight. And then we sort of developed baselines, rolling averages, and we acquire chances of being harmful, certain change being harmful, trivial, or beneficial. That's all, folks. Stay tuned and start playing with this workbook with your own data.